this is problem 13 of the Unit 3 test. And what we're looking at here is, I think we're looking at sort of like we're looking at GPA and starting salaries after you graduate college. So you could sort of think of the response variable is starting salary, and then your GPA as the predictor variable. Okay, so as you get a higher GPA in college, maybe there's some kind of linear relationship. Okay, I have no idea. Okay, but that's what they're telling us. And they tell us that R is 0.72. So it looks like a moderately strong relationship, whatever it is. Okay? And it's positive. That's about all we know. Now, here what's happened is that the data that they gave us, or the data is not available to us, so to speak. These are columns, by the way. They don't look very straight, but they're columns. So if this was our calculator, you could think that this is L1, this is L2, so L1. So the GPA data would be in L1, and the starting salary data for each data point would be in L2. Okay, so what they have done for us is that they've told us the mean and the standard deviation for each set of data. So remember, there's to make a model, you either put the data into your calculator, that's one way, but they didn't give us the data here. Or another way is to use the computer printout. Okay, which they haven't given us here, or use the formulas. And so that's what this problem is about. This problem wants us to use the formula y hat, excuse me, my hat fell off, y hat equals b0, the y-intercept, plus b1 times x, where b1 is equal to r times the standard deviation of the y data, so this data, I should say y data, and divided by the standard deviation of the x data. Okay, so we can do that. R is 0.72, and so we want the standard deviation of salary. Starting salaries is this, with a standard deviation of 8500, and we want to divide by, let's see, the first job, the GPA is 2.9 with a standard deviation of 0.4. Okay, and that should come out to be 15300. Now to calculate the y-intercept, that's y bar minus b1 times x bar. So we get the average, the mean salary is 47200 minus 15300. So you have to calculate b1 first, then we put in 2.9. And that comes out to be, what does it come out to be? 28 0.30. So the model would be salary, excuse me, this thing doesn't work too well, salary with a hat equals the y-intercept 2830 plus 15300 times GPA. Okay? So that's how you do the first part. Now the second part, they want to know, do you think these predictions will be reliable? So reliable, that should have made you think how good the model is or how useful. And that should have, if you've been practicing and learning this, it should have suggested that you need to use R squared. Okay, so here we have R. R is equal to 0.72. So R squared would be 0.72 squared. And I believe that comes to about 52%. Let's just do it real quick. 0.72 squared. Okay, so 0.184. 0.5184, I should have said. So a lot of people just sort of rounded to 0.52. So that was fine. Okay, so what I was hoping that you would say is the model I don't know. Let's just see. How about according to the model would be a better way. According to the model, 52% of the variability in starting salary after college is accounted for by the variability in college GPA. Okay, so what you could say, actually I took it either way. If you said this might serve as a reasonable model, I took that as an answer because this was really what I was after. Are you able to realize that we need to use R squared and you need to interpret R squared? That was the key point. But you might say this model may not be very useful or very reliable to answer the question directly, because approximately 48% of the variability in starting salary is not accounted for. And so the issue is that you may have a really high GPA. You could be up around a 4.0, but maybe you chose to study art, or heaven forbid become a teacher, or maybe just the social sciences. They don't pay out as much. History, they may not pay out as much. Where if you had a lower GPA, like a 2 point whatever, a 2.6, but you studied engineering, and it was a type of engineering that's in high demand, then maybe you're going to have a high salary. So there's a lot of variability about the model, which means the model may not be a very reliable predictor, because there's just other factors. Okay, now the last part was they gave you the residual, and so they wanted to know what was the actual value. So what you needed to do here is realize that this is E, the computation for E is E y minus y hat, or the residual equals the actual minus the predicted. So the residual was a negative residual, so you just plug that in. And then the actual we don't know, so let's just call that y for right now, minus, and then we need to use the model to predict. So the model was it 2830 plus 15300 times the GPA. So we were told the GPA was 3.3, so we just plug that in. Okay, and then what happens is you just solve. This is a number, so you're going to add it to both sides. So you add this to both sides, and so you get a value for y. And it should have come out to be 51440. Okay, and so you should have said, according to the model, and the given residual of negative 18080 his starting salary is approximately $51,440 a year. Okay, so that's do this. Good luck next time around.